In this video, I'm overclocking the Orange Pi 5 Max 16GB single board computer all the way up to 2647 MHz in 5 minutes or less. I'll speedrun you through the configuration and provide some notes and tips along the way. Please note that this is for entertainment purposes only and not the whole picture. If you want to overclock your Orange Pi 5 Max, have a look at the longer SkatterBencher video that's already up on this channel. Alright, let's do this. I'm using the official Orange Pi 5 Max Debian Bullseye image available from the Orange Pi website. When you've entered the operating system, open the File Manager. Navigate to the boot directory and open the Orange Pi environment text file. The Orange Pi 5 Max device relies on this document for configuring the device during boot. Make sure the parameter fdt file links to RK3588 Orange Pi 5 Max.dtb. This ensures that the steps we're going to take will likely apply to your device as well. If the file isn't there, don't proceed. Navigate to the boot DTB rockchip directory. This folder contains the device tree binaries, or DTBs. A DTB describes the hardware infrastructure to the Linux kernel. Create a new folder called Overclock on the desktop and copy RK3588 Orange Pi 5 Max.dtb from boot DTB rockchip to this directory. Open a terminal in the new directory. Use the DTC compiler to decompile the DTB file. This will convert the device tree binary in its human-readable device tree source format. Open the RK3588 Orange Pi 5 Max.dts file with a text editor. Now we will prepare the device tree source file for our overclocking parameters. For cluster 0 OPP table entry, remove all the OPP-JM entries, remove all the OPP microvolt-LX entries, set all OPP supported hardware to FFFFF, and set all OPP microvolt entries to 1.5 maximum voltage. In hex, that's 16E360. This ensures we can have the 4 A55 cores and Dynamic IQ Shared Unit or DSU PVT PLLs run up to 1.5 volt. For cluster 1 OPP table and cluster 2 OPP table, also remove all the OPP-JM entries, remove all the OPP microvolt-LX entries, set all the OPP supported hardware to FFFFF, and set all OPP microvolt entries to 1.5 volt maximum voltage. Again, that's 16E360 in hex. This ensures we can have the 4 A76 cores and respective PVT PLLs run up to 1.5 volt. For DMC OPP table, again, remove all the OPP-JM entries, remove all the OPP microvolt-LX entries, set all OPP supported hardware to FFFFF, and create a new OPP at 3200 MHz, using the same voltages as the previous highest OPP. This ensures we'll be able to increase the memory frequency up to LPDDR5 3200. For GPU OPP table, again, remove all the OPP-JM and OPP-M entries, remove all the OPP microvolt LX entries, and set all OPP microvolt entries to 1.5 volt maximum voltage. Again, 16E360 in hex. This ensures we can have the ARM Mali G610 integrated graphics PVT PLL run up to 1.5 volt. For RK8602 at 42 and RK8602 at 43, set regulator max microvolt to 1.5 volt. Again, that's 16E360 in hex. This ensures the voltage regulator for the two Cortex A76 clusters can output up to 1.5 volt. For DC-DC Reg 1, Reg 2, and Reg 5, set regulator max microvolt to 1.5 volt. Again, 16E360 in hex. This ensures the voltage regulator for the GPU, Cortex A55 cores, DSU, and dynamic memory interface can output up to 1.5 volt. Then save the DTS file. Now open a terminal in this directory. Now use the device tree compiler to turn the DTS into a DTB. This will convert our modified device tree source in a machine interpretable device tree binary format. Return to the file manager. Create a new document called opi5m_oc.dts. Now we will prepare the device tree source for our overclock settings. What we'll do is increase the target operating voltage of the highest entry in every OPP table. The Rockchip RK3588 PVT-PLL technology will then automatically increase the operating frequency to match the increased operating voltage. The target voltage for the A55 cores and DSU is 1.25 volt. For the A76 cores, it's 1.3 volt, and for the GPU, it's 1.1 volt. Return to the terminal window. Now we can use the device tree compiler to turn our DTS into a DTBO file. This will convert our modified device tree source into a machine interpretable device tree binary overlay format. Copy the DTB file in boot DTB Rockchip. This will make sure that our DTB is in the directory with all the other device tree binaries. Create a new overlay user directory in boot. This creates a folder for the device tree binary overlays. Now copy the device tree binary overlay into the overlay user folder. Type sudo nano boot orange pi environment.txt to open the boot configuration text file. Now we will update our boot configuration with the overclock settings. Make sure to first comment out the original FDT file line and add a new FDT file line linking to our unlocked DTB. And then add a new line, user overlays is opi5m_oc. Press Ctrl O to save the file and then Ctrl X to leave the text editor. Now clone BoogiePop's RKDDR GitHub project. This will help set the memory overclock. Type sudo rkddr to open the application. Navigate to LP5 and set the first line to 3200. This will make the LPDDR5 memory run at 3.2 GHz or DDR5 6400. Then exit the application and confirm the settings with Y. After a reboot, the Orange Pi 5 Max is now running at its overclocked and overvolted parameters. We rerun some benchmarks to ensure everything works as intended and check the performance increase compared to the default settings. Higher is better, and all of our benchmark results are higher. When running Jeff Geerling's high-performance LinPack benchmark, the A55 cluster clock drops as low as 2069 MHz The A76 cluster 0 clock drops to 2520 MHz, and the A76 cluster 1 clock drops to 2561 MHz. The peak SoC temperature is 66.5 degrees Celsius, and peak wall socket power draw is nearly 40 watts. And that's it. I thank you for watching, the YouTube members and the patrons for the support, and see you next time.